If Michael Jordan has a vertical leap of 1.29 meters, then what is his takeoff speed and his total hang time? Total time to move upwards to the peak and then return to the ground. So there's two questions here. The first one is what is his takeoff speed, and the second is what is his hang time. Well, let's see what I know. Currently, I know that Michael Jordan is not moving at one place. Velocity equals 0 meters per second. So right here, I know that Michael Jordan does not go up anymore or does not move down anymore. And since we're talking about the y direction, I know that the acceleration due to gravity is negative 9.8. And the problem gives me that this distance in the y is 1.29 meters. Well, let's apply it. Now, considering that I want to figure out my first problem of Michael Jordan, and his takeoff speed, I see that Michael Jordan is going in this direction. So it's a positive 1.29 meters. I know that my velocity final at the very tippy top, because I'm going to ignore this section, equals 0 meters per second. I know that my displacement in the y-axis is 1.29 meters, and I know that the acceleration due to gravity equals negative 9.8 meters per second squared. The thing that I'm looking for is velocity initial, how fast he leaves the ground. And I'm going to use meters per second. The formula that I'm going to use is velocity final squared equals velocity initial squared plus 2 times acceleration times distance. If I replace numbers for letters, I see that my velocity final is 0 squared equals my velocity initial, I don't know, but I need to square it, plus 2 times negative 9.8 times the distance 1.29. Now, 0 times 0 is 0 equals velocity initial squared, and when I solve this, I get negative 25.284. Now I need to be careful in order to get VI all by itself. I'm going to add 25.284. That cancels, but I'm going to do it to this side as well. Velocity initial squared equals 25.284. But this pesky square, I'm going to take the square root. My velocity initial equals 5.02839 meters per second. The correct number of significant figures is 3, so 5.03 meters per second.